Hi, welcome to RAR Today I'm doing a series of videos on higher order polynomials. This video says find a fifth degree polynomial function, g, with real coefficients with 1/3, 2, and negative I as zeros, and 2 has a multiplicity of 2. That means really, this is 3 of the zeros, but there's another 2 and there's a positive I as well, because complex roots always come in complex conjugates with the positive and the negative. I also want to note that I is equal to the square root of -1 and I squared is equal to -1. All right, so step 1, we know that g of x is equal to, if, I have to do a little bit of work. If x is equal to 1/3, if we multiply that 3 over, clearing our fraction, then 3x is equal to 1, or 3x minus 1 is equal to 0. So 3x minus 1. For the 2's, it's x minus 2 and x minus 2. And for our i's, we have x minus I and x plus I. We also have a leading coefficient of 4, but that's way at the end of the process. We have 5 little bubbles of parentheses we need to clear out before we even begin to think about the multiplicity or the leading coefficient. Coefficient, of course, is number multiplied to a variable. Okay, so the very first thing I want to do is multiply all of this out. I'm going to start with multiplying out the 2 i's, because that should clear out the i's. This is the same as the difference of 2 squares. I'm also going to do the multiplicity of 2. There's no reason not to do the first 2. There's something nice about doing the ones that are the same. So if I start here, I get x squared minus 2x minus 2x plus 4. And I have x squared minus 4x plus 4. I'm going to bring this 3x minus 1 down. These multiply out to be x squared plus ix minus ix minus I squared. Of course, I squared is -1. Those cancel. X squared minus a -1, which means this is going to be x squared plus 1. All right, so the next thing I want to multiply out is the 2 binomials. I think that'll be the easiest next step. So 3x minus 1 times x squared plus 1. I get 3x cubed plus 3x minus x squared minus 1. There are no like terms there, which is why I did it that way. So now I'm going to rewrite all of this. I'm going to put this in descending order. So what I want to do next is I want to multiply x squared minus 4x plus 4 times 3x cubed minus x squared plus 3x minus 1. Okay, so if you're not very versed in multiplying polynomials, a 3-term polynomial times a 4-term polynomial, you're going to end up with 3 times 4, 12 terms. I know, it's kind of ridiculous. This is why I like doing the distributive property with stacking. If I distribute each of these 3 terms into each of these 4 terms and I stack all of my like terms, it'll be very, very organized and it'll be easy to see what's going on. So I'm going to start with the x squared. So I'm going to multiply x squared to each of these. I'm going to end up with 3x to the 5th minus x to the 4th plus 3x cubed minus x squared. So when this multiplied through, there were 4 terms here times this 1, 1, 2, 3, 4. I have all of my terms here that I needed. Now I'm going to cover that up because what I really want to focus on is this negative x to the 4th multiplying through to all of these. Negative x to the 4th times 3x cubed. It's going to be a 4th term, so I'm going to line it up, and I'm going to get negative 12x to the 4th. A negative times a negative is a positive. 4 times 1 is 4. X cubed. Negative times a positive is a negative. 12x squared. Negative times a negative is a positive. 4x, there's no like term, so it hangs out by itself. 1, 2, 3, 4. I have all 4 of my terms because I'm lining everything up, and every distributive property has its own line. Not only will adding later be easier, it's really easy to see that I have everything correct. All right, I'm going to cover up the 4x. I'm going to go to the 4. 4 times 3 is 12. It's an x cubed plus 12x cubed. 4 times -1 is -4 minus 4x squared. 4 times 3 is 12 plus 12x minus 4. I have 4, 8, 12 terms. That's what I told you we would need. Now we just add down. All right, so I have 3x to the 5th. 12 and 1 is 13x to the 4th. 4, 16, 19 plus 19x cubed. This is getting very, very long. 16, 19 minus 19x squared plus 16x minus 4. So if we look at all of this, 16, this should be a 17. So that's only a 1. All right, 3, 13, 19, 17, 16, 4. Hoofta. There is a lot going on there, a lot of odd numbers. Okay, so the next thing is, it says that the leading coefficient is 4, but this is 3. So to get the leading coefficient of 4, I need to multiply this through by 4/3. Yeah. And I need to distribute that to everything. So that, I'm just going to go straight down. So that g of x equals, well, if I multiply this first term by 4/3, the 3's cancel and I have 4x to the 5th. That's what I'm supposed to have. 3 doesn't go into 13 and it's prime, so there's no reducing. So I'm going to end up with 52/3 x to the 4th. 19 is also prime and there's no reducing there, so I'm going to end up with 76/3 x cubed. 17 is also prime, there's no reducing, and so I'm going to end up with 68/3 x squared. This is not prime, but 3 doesn't go into 16 and there's no reducing, so I'm going to end up with 64/3 x. And last but not least, I'm going to end up with 16/3. And this is, for the win, one of the uglier functions I have written with my coefficient of 4. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.